Hello, so in this video we're going to look at trying to find a particular solution when this right-hand side is a sine function. Oh, and by the way, I've said it in brackets or cosine here because it is actually exactly the same for cosine. So I'm just going to work through the sine function for the moment, but you will see at the end of this video that actually it's going to be exactly the same for cosine as well. But okay. Let's just kind of work through it. So basically, in kind of a couple of videos now, I showed you that the complementary solutions, the solution to the homogeneous equation, okay, was this thing here. Okay, I showed you that. You can verify it yourself if you didn't see it, just by solving by the characteristic equation. Dead easy to do. Okay, and basically what we're doing is by the method of undetermined coefficients. So we can do that because this -3 and -4 is constant. Yeah, it doesn't depend on t, so it's constant. So therefore, we can use the method of undetermined coefficients. Okay, to try and guess what the solution is, or try and find a particular solution effectively, because of course the general solution will be to this thing will be y equals the complementary solution, which we've got, plus some particular solution to this. So in other words, if we can find a certain solution that satisfies this, then that will be the particular solution. Okay, and if you remember, we did that with the exponential case. I'm going to go through this a little bit quicker than I did with the exponential case, hopefully, because I've kind of got a lot to get through. So I'm not going to talk in as much detail. I don't want to repeat myself too much, right? So, I recommend go through. If you want to see why I'm doing each step, go and watch the exponential video, okay? So basically, the whole idea is that we look at the right-hand side, because we want to find a solution. So we want to find y equals that satisfies this, such that the left-hand side will make it equal to the right-hand side. Well, look, the right-hand side is a sine function. So it makes sense then that when we kind of go through, when we take the function, when we differentiate it, that we'll end up with a sine function. So therefore, it kind of makes sense that the original function that we had was a sine function. Yeah, because it would be something involving sine. So let's have a look. So let's say, for example, that y equals something involving sine, something involving my sine here, okay, but it won't necessarily be 2, because this 2's probably come about as a result of multiplication and differentiation and so on and so on. So let's just call it some constant. Let's just call it some constant a. Okay, so it's a times sine, basically. Now, by the way, if you try this, this actually turns out wrong. It actually turns out wrong. But I just want to show you, because it kind of intuitively, if this was the first time that you looked at this, it kind of intuitively makes sense if you're just kind of following the logic from the exponential case. If you're trying to follow the logic from the exponential case, it kind of makes sense that you just look at the right hand side and stick a couple of constants in there, and therefore it makes sense that your particular solution will look something like that. Well, actually, if you do it with this case, you do it with sine and cosine, that's actually wrong. That's actually wrong, but I want to show you why it's wrong, so that hopefully then you don't fall into the same trap. Okay, so basically let's carry on with this example. So let's first of all, we've got y here. We also need the derivative and second derivative as well. So the first derivative of this thing is going to go a cos t, yeah, and the second derivative is going to go minus a sine t again. Okay, so hopefully maybe you might be able to see why it's starting to go wrong, because when we differentiate it, we will end up with a cos somewhere along the line, either down here or up here or whatever, but we will end up with a cos somewhere along the line. So we've ended up with a cos in here. Well, there's no cos in my final answer on the right hand side, which kind of makes sense, kind of suggests that perhaps we're going wrong somewhere. But let's carry on anyway. So basically now the idea is that we plug this back into here, right? So same thing as we did before. We just take that and plug it in there, so we end up with 4 minus 4a sine t, okay? And then what we do is we take this and plug it in there, so the first derivative, plug it in there, so minus 3a cos t, okay? And then we take the second derivative and plug it in here, so in other words, minus a sine t, okay? Then we just do a little bit of tidying up now. So let's just do a little bit of tidying up. So I've got minus a sine t minus 4a sine t. This is going to become minus 5a sine t, minus 5a sine t. Then I've got a minus 3a cos t left over. So minus 3a cos t, okay? That's equal to my right-hand side. It's equal to my right-hand side, 2 sine t. So basically now, just by comparing coefficients, if you like, there is kind of, because I've got a sine on my left-hand side, which is fine. I've got a sine on my right-hand side, so I can basically say that, minus 5a equals 2. Yeah, that thing must equal that thing then, because, I've got a sine here and a sine here, so therefore minus 5a equals 2. Just compare coefficients, I've got a sine term here and a sine term here, so therefore the coefficient with the sine term must be the same. So minus 5a equals 2, so I end up with a equals minus 2 over 5, so minus 2/5, okay? But if you like, I've also got a cos term on my left-hand side. Well, I haven't got a cos term on my right-hand side. Or at least I have, but it just means that my coefficient of my cos on my right-hand side must be 0 in order to make this disappear. So this must be 0 cos t in order to make it disappear. So basically what I can say then is that minus 3a equals 0. So minus 3a equals 0. So basically from this I get a equals 0. A equals 0. Well, hang on a minute. I've just said that a equals minus 2/5 and a equals 0. So therefore that's impossible. I've come up with two answers for a. And there's no other way that I could have got that except for the fact that my original guess must have been wrong. In other words, that is not a solution to my original equation. So that is not a solution to my original equation. Okay. So we kind of need to improve our guess. We need to make another guess. So it's not going to be something involving sine. Okay. But look, basically, this is what we've got. This is what we've got. So we want to look then at the right-hand side. Well, can we think of a function that is related to sine? Yes, we can. It's cos. Because if I just draw out the graphs of sine and cos, okay, and if I just take my axes away, so this is cos, and this is sine. Hopefully you can see that they're related to each other, but I just, hopefully you realise they're related to each other. But if I take the axes away, okay, they're exactly the same shape. And actually, you'd be forgiven for thinking that, okay, I haven't drawn it particularly very well, but you'd be forgiven for thinking that they are exactly the same graph. So basically, it's just where they lie on the axis, or where they lie, their position in relation to the axis, which is known as the phase. Their phase is different because they lie at different points, on the axis. When I put my axes back in, they lie at different points on the axis. That's all it is. Okay, that's the only difference between them. Otherwise, they're exactly the same. So what I'm going to do is I'm going to say, well, sine and cos are related to each other. They're almost identical. They're kind of cousins, if you like. Or maybe not cousins. That's the wrong analogy. Maybe they're identical twins. But identical twins are very, very rarely ever absolutely identical. Yeah, there's always ever so slight differences between them. Yeah, ever so slight differences between them, which when you look carefully, you can only really see. So this is the whole idea here, that, sine and cos are really identical twins of each other. It's just one is kind of, they're at different phases. There's ever so slight differences, and the differences are where they lie on the axis. So in other words, what we're saying here is that if we try a solution involving both sine and cos, which are identical twins, just with ever so slight differences between them, so then basically if we try a solution involving sine and cos, so sine t and cos t, involving sine t and cos t, then basically, and if we add the two together, so write them as a linear combination with constants in front of them, so a and b, this is just a linear combination, yeah? If you want to put two things together, the best way to put them together usually is in a linear combination. So you've got two solutions, two functions, whatever they may be, and you want to combine them together in some way. Probably the best way of doing it is in a linear combination. So you add them together and you stick constants in front of them. Yeah, and that's probably usually a good guess. Okay, if you're not sure. So basically, this is the solution now that we want to look for and see if this works. Okay, because basically sine and cos are related to each other. So this is why if we had a cos on the right hand side, this would be exactly the same solution. We'd use exactly the same solution because of course it takes into account of both sine and cos, which are pretty much identical twins, right? So first of all, then we've got y equals this. Okay, so therefore we also need the derivative of y and the second derivative of y. So let's have a look. So first derivative of y is, what's the derivative of this thing? It's going to be a cos t, okay? And then what's the derivative of this thing? Well, it's going to be minus sine, so it'd be minus b sine t. Yeah, cos goes to minus sine when we differentiate it. Okay, and we also need the second derivative as well. So in other words, the second derivative is going to be the derivative of this thing, which is going to be minus a sine t, and the derivative of this thing, which is going to become minus b cos t. Okay, so that's the whole idea behind that then. So the idea is then as we just plug these back into there. Okay, so let's see if we can do this then. So I want to replace that with that. So in other words, with the y. So let's just replace that down there. See if we can do that. Oh no, it doesn't quite fit. Oh, rubbish. was trying to be clever. Didn't quite work. Okay. So this is minus 4 lots of that. Minus 4 lots of all of that. Okay. And then we've got minus 3y dash. So let's move this over a little bit. So minus 3y dash. So in other words, minus 3 times all of that thing. Yeah, that works. So minus 3 times all of that thing. And then just y dash on the end. So y dash. So just all of that thing. Just over here. Okay, cool. So let's just expand this out then. So we'll end up with a sine t minus b cos t minus 3a, and then just multiply through by minus 3a, so that becomes plus 3b sine t. So multiply through by minus 3, yeah? And then multiply this through by minus 4, so this becomes minus 4 in here as well. Okay, and that equals 2 sine t. So the idea is then is we want to pull all of the sines together, or collect all the sines together, and collect all the coses together. Okay, and then we could just play the game of comparing coefficients like we did before. So we've got a sine there. So we've got a sine t there. A sine t there. We got that's cos, plus 3b sine t there. Okay, and then we've got minus 4a sine t there. Okay, and then that's all got to be equal to the thing involving sine on the right hand side. So 2 sine t. Okay. And so therefore, okay, then we can do exactly the same for cos. So collect together all the coses. So we got minus b cos t, okay, minus 3a cos t, yep, and then minus 4b cos t there. And that's involving the thing on the right-hand side, which is involving cos. Well, there's kind of a cos hidden there. If we just say, well, it's going to be 0 cos t, because that will just make that go away, right, if the coefficient's 0. Okay, so in other words, it's just a game of then comparing the coefficients. The first thing I'm going to do is just get rid of the sines, okay, and the coses in each case, because that just kind of makes the way gets in the way. Okay, so in other words, what am I left with? I'm left with a minus 4a. So that's going to be, what's that going to be? It's going to be minus 3a, yeah, minus 3a. Oops, I forgot there's a minus up here. Oh, when I copied it down, yeah, sorry about that. When I copied it down, so let's just go there. When I copied it down, I forgot the minus. Rubbish. There is a minus in there. So there's a minus there. There's a minus a there. So I end up with minus a. Yeah, you wouldn't make that mistake in the exam. It's just when I was copying, I didn't quite copy it all. So minus a there and a minus 4a there. So that makes minus 5a. So minus 5a. Okay. So minus 3b minus 5a equals 2. And then down here, get rid of the causes again, because they just get in the way. Okay. So I've got minus b minus 3a minus 4b. So in other words, minus 3a minus 5b equals 0. That's just a set of simultaneous equations that I'm going to solve. It's a set of simultaneous equations that I'm going to solve. Okay, so what I'm going to do then, I'm just going to swap these around so hopefully you can see it. And I'm trying to solve it by elimination, right? So I'm just going to swap that with that, and that with that. There we go. So I've got the a's written underneath each other. That's just solving a set of simultaneous equations. So just very quickly go through it. I'm going to multiply this by 3 and this one by 5. Okay. So I end up with plus 15b minus 25a. Okay, equals 10. And then down here I'll end up with minus 15b minus 9a equals 0. Okay, so now let's try and solve these two things. So I'm just going to add these two together. So what do I end up with? Well, that's going to cancel. That's going to cancel with that when I add them together. So plus 15 minus 15 is going to go to 0. Just add these two things together. I end up with minus 34a. Okay, and this is going to equal 10. So in other words, what I end up with is that minus 34a equals 10. So therefore, a must equal to minus 10 over 34. Okay, minus 10 over 34, which I can simplify down to minus 5 over 17. So that's what a is equal to. A equals minus 5 over 17. So what did we have originally? We had the equation 3a. So let's just look at this first equation first of all, because I think it's going to be a little bit easier to solve maybe. Or is it? No, actually, I'm going to stick it into this equation, this equation before I changed it. So what were the equations that I ended up with that I had originally? Okay, so these were basically the equations that I had originally. Okay, and so therefore what I'm going to do is I'm going to plug that into my second equation to find out what b is. So I end up with minus 5b minus 3a equals 0. So a is just going to be equal to minus 15 over minus 5 over 7. So that's going to become times minus 5 over 17. And that's going to become a positive in there. Okay, so just replace that in there. So therefore this becomes then 15 over 7. 15 over 7. So then if I just do a little bit of rearranging, I take that minus 5b over to the other side, so that becomes 5b equals that. So therefore, what does b equal? Then if we just divide through by 5, so that becomes then 3 on the top. So it becomes 3 over 17. So b is equal to 3 over 17. So I've got a is equal to minus 15 over 7, and b is equal to 3 over 17. So what was my original what was the original thing that I tried? Where was it? Oh, I've removed it. Okay, so the original thing which I tried was y equals a sine t. Yep, a sine t plus b cos t. That's the original thing which I tried. Okay, and therefore I now know that a is equal to minus 5 over 17. Okay, and b is equal to 3 over 17. Okay, well, what does that mean in the grand scheme of things? Well, this thing now, this is the thing which I've just found. This is a particular solution. Okay, so therefore, what is my general solution? Well, my general solution is yc, which is that thing there. So it's c1 e to the 4t plus c2 e to the minus t. Okay, plus my particular solution. So that thing up there. Okay, so that thing up there. All right, so if I just copy that down, that is my general solution to that. So if I plug that in, my left-hand side will equal my right-hand side. And notice that if this was equally a cos, then I'd solve it in exactly the same way. I would try y equals a sine t plus b cos t, because my particular solution which I try will have both sine and cos in, then therefore it will satisfy both, whether it's sine or cos on the right-hand side, or it will have both on the right-hand side. So not just sine or cos, if it has sine plus cos, for example. Okay. Because really the way to think of it is this is really plus 0 cos t there. So basically when I've got sine and cos on the right hand side, then that's basically what we need to try.